Alright guys, welcome to Unit 8 Quiz 1 Study Guide. Number 1. The initial population of birds in a particular region was approximately 50,000. Each year the population of birds increased by 20%. What's the growth factor? This number right here is our R value, and R is what's known as the growth rate. And we want to change that into a decimal by dividing it by 100. And so that's 0.2. And as we know earlier, our growth factor, represented by the letter B, is equal to 1 plus or minus our growth rate, R, which basically I'll put R here for now. Now in this case, we can see that the population is increasing, and as such we're going to be going with the plus, and then our R value is 0.2, so that's what's going to go here. And so for this particular problem then, my growth factor is 1 plus 0.2, which is 1.2. Now, if it was telling me we were decreasing, we would have subtracted the 0.2. All right? So, 2 steps basically. Divide the percent by 100 to change it into a decimal, and then either add or subtract it from 1 based on whether it's an increasing or decreasing. All right, part B, write an exponential function to model the scenario using the variables x and y. So y is the final amount. Then we have our starting amount represented by the letter A. Then we have our growth factor, and then we have our x. And in this particular problem, we know our starting amount of birds was about 50,000. So I'm just going to put 50. You could write out 50,000, or you could just put 50. It doesn't matter. The only difference it would really make is if you knew how to interpret your answer at the end. So our answers, like let's say if we got y equals 2, that would really mean y equals 2,000. But if you actually just write 50,000 here, then the y will be literally what it is. Anyway, my b value is 1.2, and then x goes here. And there's my exponential function for part B. Part C says, use your function to determine what the number of birds will be in that region after 3 years. And for that, we're going to basically just be plugging in 3 for the power, because every year that goes by, the population increases by 0.2. So that's like we're multiplying by 1.2 3 times. In other words, 1.2 to the third power. And then you're just going to go ahead and plug that into your calculator and get your answer. Okay. Now, just so you guys know, on the test that we're having, or the quiz we're having on Wednesday, we're not going to use calculators, so we'll just stop there. Okay. Let's go ahead and move on to the next one. A disease is introduced into the region, and now the bird population is decreasing according to this function here. What is the growth rate? Write your answer as a percent, indicating whether it is positive or negative. So the growth rate can be found by looking at the growth factor. That number right there is the growth factor. Okay. So the formula that we have is B equals 1 plus or minus, and when you're doing it this way, I would just say go ahead and go with the R being plus there. The B is the one we know in this case. My growth factor is 0.75. And I need to find the R. So notice this is the opposite of the last one. On the last problem, we knew the R. We put it here to find the B. On this one, we know the B, so we're going to have to subtract 1 to find the R. And that's going to end up giving negative 0.25. Now, some of you guys might be thinking, Mr. Ray, why are you putting plus? Because it says decrease, so shouldn't we put a minus here? You can, it's fine. It's just the only difference is your answer here would come out positive, whereas mine comes out negative. Now, we want to change this into a percentage by multiplying it by 100. So basically, I'm going to take 0.25. I'm going to multiply it by 100. You can include the negative if you want to. And 100 times negative 0.25 is negative 25, and that's my percent. And I've got my sign in there. Now, let's say that you had chosen to put a minus here instead. if you put a minus here, then what's going to happen is you're going to end up with a minus here, and therefore a negative here, and you'd have to do one extra step where you divide by a -1 to get the r by itself, and you have a positive 25. But it's okay. I mean, you're just kind of ignoring the sign at that point, but you have to remember that your final answer, since we are dealing with a decreasing population, it is going to, I do want you guys to put -25% as your final answer. So the way to just let the math do it for you is just to put plus here instead. Okay, that's if you're finding r. Now, if you're doing the one up top where it said find b, you definitely need to make sure you put the right number sign in there. Next question is asking us, what's the initial population of birds? How many were there to begin with? That's just the number in front, so that's nice and quick and easy. There were 87 birds, apparently. All right, let's go ahead and move on to our next set. All right, so for number 3, it says find the y-intercept. The y-intercept could be found by taking this number in the front and subtracting from it this number in the back. So for that, you're going to need to get a common denominator, right? -3/4, which I think is easier to think of it as a decimal, so that'd be -0.75. There we go. Let's go ahead and take a look at part B. Horizontal asymptote is simply this number here, so that would be y equals -1. We're ready to graph the function then. To graph the function, you're going to plot your y-intercept and your horizontal asymptote. My horizontal asymptote is at -1, so that's, I'm just going to draw a dotted line here going from -1 horizontally. The next thing we're going to do is we're going to put a dot at -0.75 on the y-axis, which will be just a little bit above that asymptote there. And then we need to know the shape, and I gave you guys a chart you can look at in your notes. I think it was 8.3 or 8.4 notes is the chart. If your A is positive and your B value is less than 1, that means your graph is starting high on the left, coming down, hitting your y-intercept, and getting flat against the asymptote on this side. And that's what that one would look like. For part D, we're looking at end behavior here. So on the left end of my graph, it appears that the y value is going in an upward direction, so we're going to put positive infinity. And on the right end of my graph, it looks like it's reaching a y value of -1. All right, let's go ahead and take a look at the next one. All right, so we got another problem here. Y-intercept, once again, you're just going to take the a value. You're going to add to it this value. And this time we end up with a positive 0.75. I kind of skipped the work. It's actually the same numbers. The signs are just switched, so now we end up with a positive. But you would need to get a common denominator and all that. And, let's go ahead and take a look at part B. Identify the horizontal asymptote. It's this number here. It's a positive one. We're ready to graph it. And this time my y-intercept would be just slightly below the horizontal asymptote. And now, as you guys can see, my a is negative and my b is a fraction less than 1. So in that case, it's going to look like this. And once again, how do I know that? It's from the chart I gave you guys. Now, actually, I don't use the chart. I just think my way through the problem. I start by looking at the b value, and I think, okay, well, this is a decreasing function, which usually starts high and then goes down like this. But since my a is negative, I would take that shape, which I see in my head here, and I flip it upside down. But anyway, however you want to do it is fine. We're ready to go ahead and do our end behavior. On the left side of my graph, it looks like my y value is going down into negative infinity. And then on the right, wrong side. On the right side of my graph, it looks like we're reaching a y value of 1. Let's take a look at number 5. All right, let's go ahead and take a look at number 5. Get rid of these so they're out of our way for now. All right, y-intercept. Take the number in the front. It's kind of getting repetitive at this point. The reason I included so many is just so you guys can kind of get used to the process of graphing it, because I made each one of them have a different shape to graph. Getting a common denominator, we have that, and then simplification, we get that, which in the world of decimals is 0.5. The horizontal asymptote is 1. Once again, that's this number over here. Graphing the function then, I'm going to graph my horizontal asymptote here at 1. I'm going to plot my y-intercept here below that. And once again, you can look at your chart, but in this problem we have a negative a and a b value that's greater than 1. And so in that case, it's going to look like this, which means that the left end behavior is going to be 1, and the right end behavior is going to be negative infinity. All right, let's go ahead and take a look at number 6. You'll notice that in number 6 we're missing a number. We don't have the plus over here, and when you're missing a number that's being added, then it's a 0. If you're missing the a number being multiplied, it's 1. So make sure you know the difference between those two. The y-intercept then is this number plus this number, which is just 5. The horizontal asymptote is this number, which is 0. We're ready to go ahead and graph it. And I can't really draw a line where my horizontal asymptote is because it's right on this axis, so I'll just highlight it. And then we're ready to go ahead and graph it. So I've got a positive a value and a fractional b value that's less than 1. So that's going to look something like this. Meaning my left end behavior is positive infinity and my right end behavior is 0. Let's go ahead and take a look at one more graphing problem, number 7. On this one, we're missing the a value. This is the b value here, and the a is 1 when that happens. So the y-intercept is the 1 plus the 2, which is 3. The horizontal asymptote is just the 2. So we're ready to graph. Y-intercept is 3. Horizontal asymptote is 2. And then based on the shape, I've got a positive a with a b value greater than 1. So that's going to be flat on the right, hits the asymptote, the y-intercept, and then goes up. Meaning my left end behavior is 2. My right end behavior is infinity. Let's go ahead and move into our last set here. Just got a variety of problems here of evaluating exponential functions. We're just going to be plugging numbers in and simplifying. Not a huge deal. So let's go ahead and begin here with number 8. I've got 5 over 3 times 2 to the 3n minus 2 minus 2. Now you'll notice I left the n as a blank, and that's because we're plugging in the number 2 there. And so we have 6 minus 2, which is 4. So I've got 2 to the 4th power. Now in order of operations, you do exponents first, so that's going to be 16 right there. And then you do multiplication. Now when you do multiplication, I think of that as a fraction, you just do top times top and bottom times bottom. So 5 times 16 is 80. 3 times 1 is 3 minus 2. Now we need to get a common denominator. So put that over 1, multiply the top and the bottom by 3, and you're going to end up with 6 over 3, and then 80 minus 6 would be 74 thirds is our final answer. Okay? Let's go ahead and do another one. Number 9. We have negative 2 times 3 to the x power minus 2, and in this case the x is negative 1. So when you have a negative power, you want to remember that what that does is it flips it over. So instead of 3, it's going to be 1/3. All right? Then we need to do our multiplication after that. 2 times 1 and 3 times 1 is going to be negative 2/3. And once again, we need to get a common denominator. So put that over 1 and multiply the top and bottom by 3. We have negative 2 over 3 minus 6 over 3, which is negative 8 over 3. Okay. Let's go ahead and take a look at number 10. Number 10, we have 2 times 2 to the x power minus 4/3. And we're plugging in 0 this time. So exponents first. Anything to the 0 power equals 1. And 2 times 1 is 2. So now we just need to get a common denominator. Put that over 1 and multiply the top and bottom by the 3. And we get 6 over 3 minus 4 over 3, which would be 2 over 3. Let's go ahead and take a look at number 11. -3 to n, and we're plugging in -1 this time. So let's do our multiplication first. We have -3 to the power of -2. Now, there is something on here that might seem a little bit new to you. This negative here is not a part of the exponent. So that negative is going to be unaffected by the exponent. Now, a difference would be is if it was written like this, where this was in parentheses and the negative was in there with it. In that case, the -2 would apply to the whole thing. But since that negative is not in parentheses, the exponent only is directly affecting the 3. Okay? So because of that, we're only going to be reversing the 3 squared here like that. And the square is not going to affect the negative. Typically, a square would cancel the negative, right? But since it's not affecting that negative, it won't. So the negative flips the 3 to the bottom. So now we've got 1 over 3 squared. And then we have -1 over 9 as our final answer there. So that's kind of an interesting little scenario. Let's go ahead and take a look at one more here, number 12. We have 3 times 3 to the -x, and we're plugging in 2. So in this case, that could be simplified to 3 to the -2 power. And once again, that -2 only affects the number it's directly touching there. So that's going to be 1 over 3 squared, which is 3 times 1 over 9, which for multiplication you just go straight across. And we should reduce if possible. So final answer there would be 1/3. Right? And so that kind of does it. Hopefully that was helpful. These are the types of questions you guys can expect to see on your quiz tomorrow. We'll see you then. Have a good one.